13 of us in total. Wow. My first class was low, not this low, but it was pretty low too. Too strong, especially on a Friday, which I understand. I get it. I wish that my day that I could be here was Monday. Everybody comes to school on Monday, you know, or even Wednesday would be good. Like a Tuesday, Wednesday, that'd be perfect. Only I could choose.
So you don't have any power over like what days you're gonna show up? You just get kind of told, like you have to be here on Friday?
The reason that I can only be here Thursday and Friday, or because my kids are only in school on Thursday and Friday.
Oh, okay.
They're in that second group, you know, they've got them in groups right now. If they were in the first group, it would be Monday, Tuesday, but. Huh?
People have to come in here.
Oh, good. We have more people.
My siblings are going to school like full time.
Are they?
Yeah.
Yeah, I don't know a school that does that, but I didn't go to school around here. I went to school out in the middle of nowhere, so.
Oh, yeah. Well, it's all the COVID stuff.
Yeah.
We are out in Choctaw. So that's what they're doing there is like the first half of the alphabet goes Monday and Tuesday, and then the last half goes Thursday and Friday. And then on Wednesday, they just, like nobody goes.
That's what they do in Redmond too.
Yeah. And honestly, especially as it gets colder in winter and other like flu and stuff get into the mix, I don't see it changing.
Yeah, COVID's gonna get really, really bad here pretty quick.
Yeah, it's gonna get worse
It's
for
too
sure.
similar to the flu for people in the.
Oh, hey, Choctaw alum.
I know
Yeah.
way too many Choctaw alums.
You know way too many?
Yeah, and I didn't know any until I moved up here.
That's funny. I didn't grow up in Choctaw, I grew up in Midwest City, so I'm a Carl Albert alumni. But yeah, my kids really like it out there. It's kind of, I don't know, I like it too. It's kind of,
It's a nice school. Nice
it's
area.
nice. We live like out, so we're
Yeah,
like
for
Indian
sure.
Meridian, so it's kind of country.
Yeah, I know. That's what's nice about Choctaw is like you kind of live outside like the city.
Yeah. Like it's still really, really dark at night type
Yeah.
thing.
But it's still like a big community, like a decent school and stuff.
Mhm. Yeah, we love it out there. All right, guys, we'll be starting in a minute. We're not going to do too much today just because we do have pretty low attendance. I'll do with you guys what I did with my 10 class. We will start chapter 12, but we won't just like, you know, really get into it too much. Because I don't want to have to teach it again, basically, or I don't want to have to field a lot of questions about it. Oh, I'm already recording. Okay. All right, yeah, just give it a minute. We have somebody coming back in here to the class, so and we'll get started. We get an email. It's like faculty gets an email like every morning with like headlines and news and stuff. And on Wednesdays, they've been posting numbers, like virus numbers. And I mean, honestly, like they are surprisingly low here.
Yeah.
Yeah, I know a lot of people at like OSU and OU, and they're like bad.
Yeah. And I mean, it was like, I want to say they keep a running tally like from June, like so since June, and it was like less than 200, I want to say, which for our community, like there's a lot of people enrolled, and I know a lot of people are just staying home, you know, which is good. I was just really, I guess, pleasantly, you know, surprised. Hopefully I say that and I'm not jinxing us all.
I don't know, I think it's weird.
I
Like,
don't really follow this, but like, aren't the cases going down nationally or are they still rising? You know?
I don't know. I think the last time I really looked into it, it was regional, like regions are going down, but other regions are going up. Like it's just cycling through through places.
I think it's just really weird and nobody knows exactly what they're talking about. They just think that they do, so they're kind of guessing, speculating.
Yeah, there's a lot of guessing because, I mean, just think about comparing it to like influenza that's been around for like ever.
Yeah.
You know, I can't even imagine just the sheer lack of information, like lack of time and
Yeah,
observation.
Yeah, they had no clue, like, at all what they were doing.
To me, it's just sad because we actually do have like the technology and stuff to like combat with it, but we didn't do it correctly or in a timely fashion. So, and we're really irresponsible about it. We kind of went half in, so here we are.
Yeah. I mean, I was really thinking, guys, like, could you imagine this happening even 10 years ago?
Yeah,
We
right.
wouldn't have the abilities that we do now, you know,
We
because,
had a borderline pandemic 10 years ago, the H1N1 outbreak.
yeah, but I mean, like, of this magnitude, like, where people have to be
Bring
locked
that.
down. I mean, can you imagine, even 10 years ago, if I had to teach virtually,
Oh, yeah, there's no way.
it wouldn't have been this easy. I mean, okay, guys, so let's get started. So chapter 12, we're gonna look at 12.1. You guys, the homework for 12.1 is not gonna be due. We're not even gonna finish it today because, like I said, it's Friday, we got low attendance. I don't wanna push us very far.
So do we just have one homework due this week?
Yeah, just the one, just the 11.8 is due on Sunday.
Okay.
There are a lot of questions in there, but most of them you should be able to, I wasn't trying to give you busy work, but I just wanted you to practice over and over on that so you could get it real good. So yeah, it shouldn't take you that long if you haven't done it, but don't be surprised when you get in and it's like 20 questions or something like that. It's definitely bigger than our other homeworks. But yeah, lots of practice. Okay, so let's talk chapter 12. I'm hoping that chapter 12, well, I want to say is enjoyable. I don't know if any of this is enjoyable to you or not, you know. I mean, it's enjoyable to me. But when I say enjoyable, I mean, we've spent all of chapter 11 learning how to take derivatives of functions. And we haven't really talked about why we take derivatives of functions, or, you know, like, are we just cruel? Am I just making you do stuff just because, you know, but we're going to apply it in chapter 12. So you're going to see why we're doing what we're doing. And sometimes that can be really satisfying, you know, like, oh, okay, so this is for a reason, right? So we're going to talk a little bit about those reasons here. So what I'm going to start with, I don't know why I made it so lopsided. All right. Okay, so that's all on the screen. You guys, I'm gonna just draw the graph of a function. This is just gonna be, I'm just gonna call it f of x. I'm gonna make it up as I draw. So, you know, it's not gonna have an equation or anything like that. But let's say we've got some function f of x and it looks like this. Real curvy, goes on forever in both directions. You guys, you can assume, or you can pretty much guarantee the functions that we look at, for the most part, unless they're a specific application, are going to be two things. They're going to be smooth and they're going to be continuous. So there's not going to be a bunch of places with holes or undefined values, and they're going to be smooth, which means, you know, to get from here to here is connected with a smooth curve. It's not going to be any jagged edges or, you know, zigzags or anything like that. So we have these nice, smooth, continuous functions. And those are the functions we're going to be working on. So let's look at this one. I'm going to pick out some points on this function. I'm going to pick one right here, and I'm not giving these coordinates. That's not what is important. So I've got 5 points. that I've labeled on, or I haven't even labeled them. I just picked them out on this function. Remember our goal for this whole class basically is you got a function, we want to take the derivative. Now I can't take the derivative of this function because I don't even know the rule for it. I don't have numbers, I don't have an equation. But I can still tell a lot about the derivative of a function just by looking at a graph. So here's the function. Remember what you're doing when you're taking the derivative. You're finding the slope of a tangent line at any given point. So if I say, hey, what is the derivative at this point? Then you find it, you do some calculation. What we get is the slope of the tangent line. Remember, the tangent line is, they're just these little lines that you could draw at every point where they mirror the function there and they touch the function there, but they're a straight line. So again, it's kind of like linearizing the function at these little points. So there's one. You guys, if I wanted the derivative or the slope of the tangent line at this point, I would get a line that was like this. At this one, you guys, that tangent line is going to be pointing down. At this one, we're going to be horizontal again. And at this one, we would be pointing up. Let's pretend that's a straight line. So you guys, I'm not the best at actually drawing good tangent lines, but you get the point here. So I've got multiple slopes, multiple derivatives here in a picture form. Right here, this line is pointing up, right? So even though I don't know what the derivative is there, I do know it's positive, right? Because this line has a positive slope, and the slope of that line is the derivative there. So without knowing anything else about my function, I know that over here at this point, my derivative would be positive. What about this one here?
Negative,
Right, it'd be negative because
because
you
it's
can
good.
see.
It's going down and slanting.
Yeah, it's slanting down, so its slope would be negative. So in this area where we're going up, I have a positive derivative. In this area where we're going down, it's negative. Over here, it'd be positive again.
Right.
What about here and here?
Positive.
You think?
I just randomly guessed.
Well, actually, it's kind of a trick because it's neither. You guys, what's the slope of a horizontal line? Anybody remember? It's 0. So the derivative will be 0 there. So you find the derivative of the function, you put in this point, you will get 0. And it'll happen again here. So you guys, look at this picture. All of these derivatives would be positive values until we get to here. We would hit 0. We go through 0 to the negative values. And then we get here, we're at 0 again. We go from negative through 0 to positive again. Notice your graph does not change directions without going through a derivative of 0. If it never hit this 0, it wouldn't be changing directions. So you can only change from negative to positive by going through one of these 0 points. That's important to us, guys. These points where the derivative is 0 is very important to us because a lot of times it's very important to know, okay, when does this graph change from up to down? Where is it changing directions? Well, it's changing directions at every point where your derivative is 0. So I would like to find those places, even without looking at a graph, because we don't have graphs of all of our functions. And honestly, we're not going to make graphs of all of our functions. What we're going to do is we're going to algebraically find points where the derivative is 0. We have a name for these points because they're super important. They're called critical points. And today, that is our goal, to find critical points. If I can find those, I can find out what the graph is doing around them. Okay, so let's talk about how to find these critical points. We're going to have steps in our work today. And step 1, and honestly, in every single section in chapter 12, step 1 is the same. we take the derivative. So step 1. Take the derivative. Now you guys, I'm actually gonna start saying take the first derivative. Not gonna really matter to us today, but next lesson, we're gonna learn the second derivative. So I am gonna specify here that step 1 is to take the first derivative. Doesn't change anything, you already know how to take it. It's just when we have more than one, I do want to specify. Okay, so step 1, take the first derivative. Step 2, set that first derivative. I'm gonna notate it like this. Set the first derivative equal to 0. Remember, I want to know where it equals 0. How do I find those places? I set the derivative equal to 0 and I solve for x. So that's a sub-step, right? So I set equal to 0 and I solve for x. So let's think about what that's going to give us. It's not going to give us the coordinates of these points, right? It's just going to give us one coordinate of those points. It's going to give us the x values where they occur. Because remember, when you're doing a derivative and you put a value in, you put an x value in. You say, what's the derivative at x equals whatever? What I'm saying is we're finding those x values that will get a 0 out for the derivative. So, set derivative equal to 0, solve for x. Now you have found your critical points. They will be x values. So that list is going to grow, but before it does, let's do an example of finding critical points. So, no more picture. It'd be way too easy from a picture. If you remember anything from like algebra, and it's fine if you don't, but those points that I labeled, the critical points on the graph, otherwise known as local minimum, local maximum, you know, places where it changes from increasing to decreasing. We found those in algebra, but the only way we could find them then was actually by looking at a graph. Now, because we know about the derivative, I can find it without the graph. So, example. So I've got the function f of x equals, let's do 2x squared plus 8x minus 7. That'll work out nice. All right, this is my function. I don't do anything with the actual function because my first step is to take the derivative, and all the work I do beyond that is with that derivative. So step 1.
4x plus 8.
Yep, I got the first derivative is 4x plus 8. Step 2, I'm going to set that equal to 0. So right here, you're just going to replace that with a 0. So 0 equals 4x plus 8. And then,
X equals -2.
right, yeah, solve for x. This one's super easy. They're not always super easy, but this one is because it's our first example. So divide by 4. And we get x equals -2. This is the location of the critical point on this graph. This graph only has one critical point, which without looking at a graph, it tells me some things about it. It tells me that this graph only changes directions once. It should make sense to us, guys. This is a quadratic function. It graphs a parabola, right? So it's either going down to up, or it's going up to down. Either way, it only changes direction once. That's why we're only getting one critical point. I will graph this, or I'll sketch a graph of it at least at the end, but we gotta keep working. So, found critical points. Sometimes you will have more than one. So remember our factoring practice we did last time? Sometimes you're gonna take the derivative and it's gonna be something you have to factor. And remember, if you do factor, when you solve for x in a factoring situation, you get 2 answers. That would be an example of a graph that changed directions twice at 2 different places. But this one only does once because we're starting out easy. Okay, Okay, so we did this, we did that. We got a critical point, or we got the location of a critical point. Guys, I rarely care what the y value is here. It really doesn't matter much to me, you guys. We are concerned with what happens as you go along the x-axis. What happens to y is important, but that's gonna show up when I decide where is this increasing or decreasing. I don't have to know how far it's increasing or decreasing. So if I don't ask specifically, I only want the x value here. So what am I gonna do with that?
Put it in, write it as a formula, like some kind of slope, y equals mx plus b.
So I could definitely do that,
Mm-hmm.
but I don't have to. That is, so this isn't actually gonna be a slope.
Mm-hmm.
Remember, at this x value, our slope was 0.
Mm-hmm.
So that formula would be 0x plus b. It would be something,
Right.
but that's not what we're gonna do with this, guys. What we're gonna do, now that I know where it, let's say this is the point at x equals -2, and it's on my graph. Here's my next question. I already decided it's gonna change direction here. Is it gonna go from up to down there, or is it gonna go from down to up there? That's what I have to figure out now. I can do it algebraically still. I still do not have to graph it. So let me show you how I'm gonna do that. I'm gonna take my critical point, and I'm gonna put my point, or if there's more than one, I'm gonna put all the critical points on a number line. Let me show you why I'm gonna do that. I don't need a graph, I need a number line. All right, so I'm gonna draw just a basic number line. I don't care, like, you don't need a lot of values here. It doesn't even have to be to scale. What I want is I want to see your critical point or points on the line. So we only had one, so I'm just gonna put it here. -2. So think about your number line as being the x-axis because it's in x values. This is x equals -2. I want to know what the graph is doing around this point. I know at that point it's changing. I just don't know how it's changing. So do you agree with me before we even get started with this? You have to agree with me, so say yes, that a graph cannot go from one direction to another without going through a critical point. This is true. So if it's going down and then it starts going up, there's no way it didn't go through a point where the derivative was 0. It's not possible. So keep that in mind. This is the only point it can change, which means whatever happens, pick any number over here. Let's say -3. Whatever the graph is doing here is what the graph is doing in this whole interval, because it can't change without going through that -2 place. Pick a value over here. Well, we'll do that in a second. Let's stick with this value. So what we're gonna do, your critical point breaks your number line up into sections, let's call them, or intervals. I'm gonna test a number in this interval. I'm gonna put it into my derivative and see if it comes out positive or negative. Let's find that and then I'll tell you what that means. I picked -3, it's a pretty easy value. You could have picked -4, you could have picked -20 if you wanted to, as long as it's over here in this interval less than -2. Okay, so I put it on a number line. Test points around the crit points. That's what we're doing right now. I've picked some points that are around my critical point, and I'm going to test them. Here's the question, where am I going to test them? I'm going to test them in the first derivative. I'm not going to take that -3 and put it into my original function. That's not going to tell me anything. So I picked this point to test. point is going to be an x value that I'm putting into the derivative of the function. So let's remember what the derivative was.
With 4x plus 8.
Okay, so here was the derivative we found. I'm gonna put this -3 in for this x.
Uh-huh.
So let's see what we get.
20.
We get 20. Are you sure?
Yes. 4 times 3 is
4.
12.
You get 4.
It's -3 though, right?
Oh, okay.
So we get -12 plus 8, and we get 4, or -4. See guys, when I put -3 into my derivative, I got -4. Let's think about what that means. It means, and I don't even care that it's 4. What I care about is that it's negative. I got a negative derivative. That means in this whole area over here, all of these values would have a negative derivative or a negative slope of a tangent line, which tells me that in this area, the graph is going down because my derivative was negative. How do I know it's going down the whole time? Because it can't change unless it goes through a critical point. And I happen to only have one of those. Okay, so let's find out what's happening over here. You guys, I can pick any value I want that's greater than -2. I'm gonna go easy, I'm gonna use 0. 0's over here, isn't it?
Mhm.
Let's test 0 into the first derivative. So if you put 0 into that first derivative, you're just gonna get 8, right?
Right.
So it's positive.
Yep.
So again, I don't care if it's 8 or 25, it's positive. That's what I care about. So that means every derivative on this side is positive, which means my graph on that side is going up.
What? I am my own
I have
person.
not graphed
Why are you
it. I have not even stepped into the
Why are you
XY plane,
leaving?
but I know exactly, yeah, what it's gonna look like. Yes.
I think I heard something on the computer. I think one of your students had a question, or I think there might be maybe whispering to themselves.
Okay. You guys, did any of you have a question? We heard some stuff, but this speaker in here is really bad. So if you do, you might want to type it in chat. This room is, I don't know what it is. It's not great on the speaker. But yeah, you can type it in chat if you've got a question. Yeah, so I know what's happening. Now, if I wanted to actually graph this, I would need to find a couple of y values probably.
Mhm.
But luckily, I'm not gonna graph it, so I don't care. What I do care about is, first of all, in your answers, you know, for these questions, it's gonna say, what are the critical points? And depending on how it asks, it might say, where does it occur? Well, it occurs at x equals -2. If it asks you for the value of the function at that point, how could I find that?
Would we just plug that into the?
Yeah, if it says, well, what's the value of the function at -2? Plug that into your function. That's the only time you would ever need a y value, is if it specifically asks for it. So yeah, what you would do is do f. Now, if it asks for the value of the function there, did it say the value of the derivative there?
No, so we'd plug it at the original.
Yeah. If it says, what's the value here, you put it in the original. What would actually happen if you put -2 into the derivative? Well, the definition of a critical point says it's where the derivative equals 0. So you would always get 0 there. So what is the value at the critical point? Put it in the original and you're just getting a y value. It's the only time you'd ever need a y value. It doesn't ask it every time. The questions are kind of, they like to change it up. Sometimes they're going to ask for it, sometimes they're not. So you just have to be able to understand when it wants it and when it doesn't. It will always, always want the x value. But if it wants the y, stick it into your function and find it. Now, what's the other question they're going to ask? They're going to ask, where is this function increasing and decreasing?
Mhm.
I can answer that, right? I just made this nice little number line that shows.
Are we gonna have to use like interval notation for that?
Yes.
No.
Yes, I love it. All right, so it's gonna say, where are the increasing intervals of this function? You guys, increasing are the ones that you get positive derivatives for. So this one right here is an increasing interval. You
Right.
guys, we are gonna use interval notation. If you're not familiar, interval notation looks like an ordered pair. It looks like an XY pair, but it's not an XY pair. It's only in X values. So what it's gonna be is, it's gonna be leftmost endpoint to rightmost endpoint, always, and it's always left to right. So for us, let's look at our number line. It starts increasing here at -2, and it keeps increasing on forever.
So it'd be -2 to infinity.
So it would be -2 to infinity. So the way you would write it in interval notation is you'd have -2 comma infinity. Now here's the thing about interval notation. Sometimes we use parentheses and sometimes we use brackets. You don't have to worry about brackets here. I will explain the difference between the two just in case it comes up later. But you guys, if I have a parenthesis, it's going so far. Okay, you guys, if I have a parentheses here on the -2, what that means is that my interval starts here, but it doesn't actually include that value. So if you want to include your endpoint, like if you're saying -2 needs to be part of this interval, you would have to use a bracket. This means my endpoint is included in my answer. This means it's not included, it's just there to show you where the interval
But
starts.
it wouldn't be included, right, because there's 0 there.
Right, so it cannot be included, guys, because an increasing interval has positive derivatives. And we know at -2, the derivative was 0. So we're never gonna include, we can always use parentheses. And on infinity or negative infinity, you use parentheses anyway. You could never bracket that. It really doesn't make sense to say that your interval includes infinity because it's not a specific number. So you guys, you're not gonna have to worry about brackets, just parentheses, everything. You just have to be able to put it in this form. So you guys, from -2 to infinity, we were increasing. So then you'll tell me where it's decreasing. I need to erase some. All right, so that's the other part. You guys, it's the part anywhere where our derivative was negative.
So from -infinity to -2.
Yeah, so on this one, because it goes to the left forever, your leftmost endpoint would be -infinity, and it goes all the way up to -2. Again, not including that value. So that value cannot be included in either one. So guys, different ways that it's gonna ask for your answer. It's gonna possibly ask for where does the critical point occur? If it's a where, if it's a location problem, your answer is the X value. It occurs at this X value. What is the value of that critical point? That's where you would find a Y value. So if it's a where, it's X. If it's a what or what's the value there, that's your Y value. The other thing it's gonna ask for, where is it increasing? Where is it decreasing? And that's gonna be these intervals here. So you guys, we're just doing this one. There's no, okay, losing my mind. We're just doing this one question today because, again, it's Friday, our attendance is low. I really don't want to get into the ones that are more complicated without all of us, or more of us being here. It's not something I want to go over a bunch of more times, if that makes sense. So, yeah, guys, I'm not going to do another one. Like I said, just because it's Friday. I think a lot of teaching is lost at the end of the week, you know, and I always have to bring it up again later anyway. But guys, so what this means is that your 11.8 homework is the only homework you have due on Sunday. But it is due on Sunday. This homework will be tacked on to next week because we're not done with it. We're gonna keep going. So yes, we're gonna keep going with that, so there's nothing to worry about. I'm gonna open it like later if you wanna start on it, but there's gonna be stuff that you might not be able to get through. So don't worry about it at all. And yeah, that's it.
I didn't know we were still meeting, to be honest.
You didn't know we were what?
Still meeting.
Oh, yeah. That's okay. I've got it recorded anyway. All right, guys. So, out there in virtual land, that's all I got for you.
Purposes.
I will see everybody in virtual land on
Patriot.
Monday. Today is Friday.
I'm calling about the free trial of Sirius XM vehicle.